Okay, so let's start up the session. Yes, so today again we are going to discuss 4 old CAT questions which has appeared in CAT 19. So it's a basic revision, as we have decided that every 2 or 3 days we'll discuss 4 questions per day, possibly 5 questions per day of quant or LRDA. So the next will be also today's will be nothing but quant questions itself. We'll continue with CAT 19 slot 1 quant questions. So I'll again pick some questions from the different topics. So first question is again related to arithmetic. So let's see what's there. So it's given Meena scores 40% in an examination, and after review, even though her score is increased by 50%, here we need to keep in mind they are talking about it is increased by 50%, not increased to 50%. So if we'll draw it normally, suppose I'll draw this in number line format just to identify what's happening in this, right? So earlier Meena scored 40%, so let's consider this one is 40% here, and after review, even though her score is increased by 50%, so 50% of what? It's basically 50% of 40, right? That means it should increase by 20 percentage point. So it should not be 50% overall, it is increased by 20%. So that means it is increased by 20% overall. Here till this it's equal 60%, right? So according to this, C failed by 35 marks. Assuming that this is my pass mark, I'll write it on the bottom side. So C failed by 35 marks. If her post review score is increased by, again they have said increased by 20%, right? So increased by 20%, increased by 20%. So 20% of what? Of this figure, right? So now if it is increased by 20%, so 20% of 60, so basically it's nothing but 20% of 60, which is basically 12 percentage point. It is increased by 12 percentage point. So from here to here it's increased by 12 percentage point. So that means this is about 72%. Now according to this, C will have 7 marks more than the passing score. So she will have 7 marks more than passing score. So now if we identify this part, this figure is 12% point. That is equivalent to, if you consider this, right? That's nothing but 42. The basic representation is nothing but 12% is equivalent to 42. In other sense, I can say 1% will be nothing but how much? Just compare, it's about 3.5. Also we can say 100% is nothing but 350, right? So that is not required here. Now according to the question, the percentage score needed for passing the examination. So 72%, which is 7 more than the passing mark, and we know, as we have seen, that 1% is equal to 3.5. so this value should be definitely equal to 2%, right? So this is 2% here. So if I reduce it by 2%, this figure is supposed to be nothing but 70% here. So my value should be nothing but 70%. My value will be 70% here, right? So next is a question which is based on geometry. Corners are cut off from an equilateral triangle. So it's an equilateral triangle given T, equilateral triangle T, to produce a regular hexagon H. Then the ratio of the area of H to the area of T. So hexagon by triangle, right? So my basic equation is I need to find out the ratio between hexagon and triangle in this case. Let's try to identify what is my possibility. Let's have a triangle here. Let's say this is an equilateral triangle. Let's consider ABC. So this is an equilateral triangle ABC. and I want to create a hexagon. I'll take 3 cuts here. Let's say this is D, E, F, G, H and I. So according to this length, which is equal to this length, which is also equal to this length, and that will be equal to this length, as this length is equal to this, right, as they are the equilateral triangles available. So can I say that I have divided BC in 3 equal parts? I can say if this is x here, I can say this complete will be nothing but 3x, right? So I'll definitely get a relation in this case if we'll consider area of triangle DBE by area of triangle ABC will be in the ratio of 1 square by 3 square. Also you can say in the ratio of 1:9. So overall area is definitely in terms of 9. That means if I'll go through the options, suppose if I'll go through the options, the value which is a factor of 9 would definitely satisfy my condition. So possibility should be 2:3. That's my basic relation here. Or else now you can do one thing, assuming that this area is about 1 unit, this area is about 1 unit, and this area is about 1 unit, and the overall area is 9 units. That represent this will be nothing but 6 here. So according to this, the hexagon's area is suppose 6 and area of the triangle, bigger triangle, is 9. So they are in the ratio of 2:3. It should be definitely 2:3. But if I'm not working on this, let's try to identify some more thing. I'll join few more lines. Suppose I have joined these lines here. Now I can identify how many triangles are there, how many equilateral triangles are there. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right? So 9 pieces are there, 9 identical pieces are there. Out of this I'm dealing with these 6 pieces. That means it's in the ratio of 6:9, or else I can say it's in the ratio of 2:3. Fine. Next one. If the population of a town is P in the beginning of the year, then it becomes 3 plus 2P in the beginning of the next year. If the population in the beginning of 2019 is 1000, the population in the beginning of 2034, that means we are talking about a span of 15 years here, right? So from 19 to 34, if we'll consider, the span is about 15 years. So let's see what are the possibilities here. Since I'm using a variable P, whenever I have a variable available, that means I can always draw my own relations in terms of P, right? So let's do one thing. First we'll try to check what could be the relations possible and what is the scenario here. So first year it's P, next year it will be nothing but 2P plus 3 will be the value. Next year, so this is the first year, second year, let's consider third year. If we'll consider third year, it's something but twice of 2P plus 3 should be the value possible here, right, which is nothing but 4P plus 9 is the value possible here, right? Then again next year it's something but twice of 4P plus 9 plus 3, which is nothing but 8P plus 21, right? Could have been written as this could have been written as 2 square P plus 9, it's 2 cube P plus 21, it's 2 raised to 1 into P plus 3, and this is nothing but 2 raised to 0 into P, right? So I'll try to match up the value with this, assuming that p value is nothing but 1, right? So I have this value as 1 here, then it will become 5 here, right? Then this is 13, and then this will be nothing but 29. I'll take one more example just to identify. Suppose p is equal to 2. This is 2, and this value is how much? 2 into 2 into 4, 7. Then now this value is 17. Then this value $37, and this process continues, right? Now, since here p value is nothing but 1000 is p, so let's do one thing. Let's try to write the values in this format. It's p plus 3 raised to 15 plus 6. This value is nothing but p minus 23 raised to 15 minus 3. This value is p plus 3 into 2 raised to 15 minus 3, and this value is nothing but p minus 23 raised to into 2 raised to 14 plus 3, right? So now according to this, if this is 1000 on the first year, right, then next year it is supposed to be nothing but 2003, right? So I have to find out a pattern. Instead of 1000, suppose I'll keep the value as p as 1. That means this value for the very first year will be nothing but 1 plus 3 raised to 1 plus 6, which is 10, but my figure is 5, so definitely this is ruled out. If we'll take this one will be a negative value, so this is definitely ruled out. Now if we'll take this one, right, it's 1 plus 3 raised to 1 minus into 2 minus 3, so that is 8 minus 3, which is 5, which is still possible. And the next one is this one, which is again a negative, which is also a positive value here, but that is not equal to 5, right, because this value cannot be equal to 2 here. So sorry, not a positive value, it's a negative value, so this is also ruled out. So ideally my answer is supposed to be third one, but let's cross check with the next value here. So as we have seen, it's saying but p plus 3 into 2 raised to n minus 3, where n is the year available. So according to this, suppose n is nothing but 2. So according to this, 1 plus 3 is 4 into 4 minus 3, which is 13. That definitely satisfies my condition. So this should be the answer possible here. But let's check with p value as 2 here. So here I'll take 2 plus 3 into 2 raised to 2 minus 3, right? So 20 minus 3, which is 17, which still satisfies my condition. right? So if we're working on this one, then I can identify that the answer is definitely third one. The good part is whenever it's a progression question, we should always utilize our options to work on the value. Better to utilize the options. Correct. Next one is moreover related to numbers. The product of two positive number is 616. So first thing is, let's try to write 616 as the product of the prime factors. That's 2 into 2 into 2 into 7 into 11. So what are the possibilities? Suppose if I'm talking about the possibilities, the numbers can be written as, let's keep these values together. So it's 11 and 56, right? Then I can have 22, 28. Then the next one is nothing but then I'll take the value as 14, 44, right? And then the next value I can take is nothing but 788. For the time being, let's try to check what are the summations possible here. Right. So let's check what are the summations possible in this case. Here, if we'll take the summation, 56 plus 11 is nothing but 67, right? Anyway, this is not there in the option. This is 50, which is available there, right? Then this one is nothing but 58, which is also available in the option. 88 plus 7 is nothing but 95, which is also available in the option. And let's see any other combination is possible or not, right? So we have taken 7, 11, then I can take 8, 77, which is also 85. That means all the variations are available here, right? So that means I cannot directly go by the options to work on the value. So let's go by the basic calculation here. According to this, suppose the values are a and b. My condition is if the ratio of the difference of their cubes, so a cube minus b cube divided by a minus b whole cube is 157:3. So if we'll consider, if a minus b whole cube is, let's say if this is 157 and this is 3 here, that means the gap between a and b should be lesser. If we'll check, the least gap possible here is in this case. So possibly my answer should be 22 and 28. That means the summation should be 50. That is a possibility, right? So if I'm checking this, I can say it could be 50 here. But let's try to work on the calculation here. So it's a cube minus b cube. I have to utilize the formula here. There are few more things which you can do, like 157 plus 3 is equal to 160. That means the summation of these values, a cube minus b cube divided by a minus b whole cube, should be a multiple of 160, or it should be ending with 10. But again, the problem is every value will end with 10 here. So let's go by the formula. There is no other way out, so let's use the formula here. So a cube minus b cube, I can write this one as a minus b into a square plus ab plus b square divided by a minus b whole cube. This part is cancelled, so that represents the value is a cube plus, a square plus ab plus b square divided by a minus b whole square is equal to 157 by 3. Further, I can write the value as a minus b whole square plus 3ab, right, as it's a square minus 2ab plus b square plus 3ab divided by a minus b whole square should be equal to 157 by 3. Now further, if we'll check, if we'll solve this, this is cancelled out, so I can say 3ab divided by a minus b whole square plus 1 should be equal to 157 by 3. Now it will be easy for us to work on because I know the product is equal to 616, so I can directly utilize this. So 3ab divided by a minus b whole square is, I'll shift this value towards this side, it's 154 by 3, and a into b is equal to 616, so 3 into 616 divided by a minus b whole square is equal to 154 by 3. 4 times, that represents a minus b is nothing but 6. The difference between a and b should be 6. Now I can check the difference between a and b should be 6. That's possible in this case. That means my summation is nothing but 50. So these are the 4 questions we have discussed today. In the next one, we'll start with the LRDI part. We'll discuss 4 questions of LRDI. That's all for today. Thank you everyone.